Hello, my name is Peter Stones. I work for ESAB, and it's my very great pleasure to be able to take this time to give you my presentation. Today, I want to be talking about stainless steels. I'm going to spend about 15 minutes to tell you a few facts about stainless steels, give you a few properties, such as what makes a stainless steel, what are these phases that we hear about called austenite, ferrite, and of course we're a welding company, so we'll discuss welding and what happens if you don't follow the recommended parameters. So the title of the presentation, as I say, is going to take about 15 minutes. Why can't you weld stainless steel? So obviously it's just a taster of the subject. If you wish to know any more information, then please feel free to get in touch. Our contact details will be listed. So what makes a stainless steel? So the iron with anything more than 12% chromium content generates a protective layer on the surface. The chromium in the metal reacts with air to create this chromium oxide layer. This is a very thin layer, it's only micron thick. It's a very thin layer of chromium oxide. This is very passive and it's a very good corrosion resistant layer. While ever that layer's on the surface, then you have a stainless steel. If that layer gets removed for any reason, such as chemically or mechanically, then providing the metal is exposed to air, oxygen, then it will create the chrome oxide layer again. It will regenerate. Okay. One diagram that we like to use to describe the various phases of stainless steel is this thing called the Schaeffler diagram. And essentially, there are two scales on it, the chrome and nickel. Chrome is, in a nutshell, responsible for ferrite, and nickel is responsible for austenite. So the composition of the various stainless steels that you may have heard of, 316 for example, 308s, duplexers, the content of those can be plotted on this graph, on this chart, and it describes the structure. It describes the microstructure of what you get. So we've got the austenites, austenitic stainless steels that contain a little bit of ferrite. We've got duplexers that have got 50-50 austenite ferrite, the ferritics, martensitics, and so on. So in terms of composition, then these are typically the kind of numbers that you'd expect to see for the various grades. Austenitics contain primarily chrome, nickel, moly. Stainless steel alloys can contain up to 10, 12, 15 different elements, but chrome, nickel, and molybdenum are the three key ones. In these kind of quantities, the austenitics have got a mixture of all three. Ferritics, primarily chrome. Martensitics, now there's very little difference between the ferritics and the martensitics at the lower end of the chrome scale. The thing that differentiates them is the carbon content. Okay, so it's always less than 0.1 for a ferritic. Duplexers, as we say, have got 50-50 austenite ferrite, but they generally can contain chrome, nickel, and molybdenum. And these specialty alloys, so we're talking super austenitics, so that the higher end of the alloy scale, so greater than 20% chrome, greater, some can have 31, 32% nickel, for example. And we'll describe each of those in turn now. So an austenitic, under a microscope, this is what an austenitic stainless steel would look like. So something like a 308L, we say it's an austenitic, but it actually contains a little bit of ferrite, anything up to 15%, depending on the way it's been manufactured. So the microstructure here is the white background is austenite with the lines of ferrite in black. Now, the thing about these is they're easy to produce, they're ductile. The structure, this atomic structure, means that it makes it very ductile, and very ductile, very strong, and it's got very high toughness at low temperatures. In terms of weldability, very easy to weld, even in thick sections. One thing to watch out for with these is the thermal expansion. So this can be anything up to 50% greater than carbon steel. So something to watch out for a welder that's not typically familiar with welding stainless steels. Ferritics, what we see here is a microsection of a joint. So we've got base metal that's 100% ferrite, and then the weld metal. The weld metal's got bigger grains. It's been heated up. Now, the properties of a ferritic stainless steel, they are magnetic. They're, because of the amount of ferrite in there, they can dissolve impurities in the steel. So if you get some impurities such as sulfur, for example, phosphorus, in the base metal, then the ferritics are good for basically dissolving that. They're not as weldable as an austenitic, and it's really not advisable to weld a ferritic in a thick section. So preheat may be required on the thicker sections. You need to be careful with the thermal stresses on the ferritics, particularly in the thick sections. The grain growth that we see here, heating causes grain growth, as it does with any steel, but this may become a problem with the ferritics, okay, such that you're losing all the strength. Typically, people can weld a ferritic with a normal 300 series austenitic stainless steel. In terms of duplex, what we see here is a 50-50 split of austenite and ferrite. What we want to see is a nice even distribution of the austenite and ferrite together. The result of the combination of the austenite and ferrite in the duplex stainless steels is that you've got twice the mechanical strength than a standard austenitic. They are trickier. Duplexes are trickier to manufacture, just because you've got the chrome, the nickel, the molybdenum content, right? Doesn't automatically produce a duplex. You've got to be careful the way that it's manufactured. Duplexes are quite easily weldable, even in thick section. We not recommend preheating or post-weld heat treating, and heat input and interpass temperatures are critical. What we need to do is make sure that the microstructure of the weld ends up being a duplex again. So in terms of these super austenitics, something like a 383. So we're talking 27 chrome, 31 nickel for molybdenum with copper, low carbon. So typically these have got very big grain sizes, you can see. So these have got 0 ferrite in there. So you have to be really, really careful with the heat input. Certainly no preheat, no post-weld heat treatment. Interpass is critical. Absolutely keep it below 150 degrees centigrade, for example. And we'd advise the weld bead shape to be either flat or convex. So you don't want a great big bead sat on top of the metal. The martensitic, these are typically, so these have got 0 ferrite in them as well, but it's purely martensite. And the properties of martensite is that it's very hard and very brittle. So it's got very good high temperature strength. And on the other side, very poor low temperature toughness. They are not readily weldable. Usually the low carbon grades are the easiest ones to weld. They are hardenable, so they will get harder. You will more than likely require stress relieving. This just wants to break. This just wants to snap because it's so hard and so brittle. The microstructure of this is such that it doesn't take very kindly to being heated up. It doesn't like thermal stress, so you will need to be very careful with the heating and the cooling. In terms of corrosion, this illustration shows the various grades of stainless steel and the effect of this G48 corrosion test. So all of these test pieces have been immersed in this 6% ferric chloride at 80 degrees. So whatever, it's a nasty corrosive liquid, and all of these test pieces have been immersed for the same amount of time. You can see on the left-hand side we have a 316 stainless steel, which it's a stainless steel, but you can see it's been very badly eroded on all surfaces, and you have these things which are pits. So it's a bit like an iceberg. There's a pit on the surface, a dot on the surface, and underneath the damage is much worse. Over the other side of the scale, we have a duplex 2205, a duplex stainless steel. So that has been quite badly affected as well. But if you look at something like a super duplex, that 25% chrome super duplex, it looks like it's hardly been touched. So that's the effect of the various grades of stainless steel. So yeah, this is a stainless, but it's still been quite badly eroded. So you have to ensure that you're choosing the right grade for the right purpose. With too much heat, what we have on the left-hand side is what looks like a very nice TIG weld. It looks to be fine. However, when it was sectioned and the microstructure was checked, it was overheated. And what happens with that is you produce, it's stainless steels, you produce this thing called sensitization. So you can see at the grain boundaries, you've got carbides being generated at the grain boundary. So they're precipitating. You're taking the carbon out of the grains, and they're moving towards the grain boundaries. This is called sensitization. Okay, and it essentially makes a very, very poor metal in terms of corrosion resistance and mechanical strength. And this can happen as low as 750 degrees. So if you've got a weld at whatever thousands of degrees, if you maintain the weld, you're not cooling it fast enough, or you've overheated, you put too much heat in there due to not following interpass temperatures or the weld parameters. There's too much heat in there, then you can get this sensitization, and that's what it looks like, and that's bad. So to finish off, my last slide just shows the effect of post-weld cleaning. So this is the resistance to pitting corrosion. So the higher up this scale, then the better the resistance to the pitting corrosion. That's the corrosion that you saw in those test pieces. So you start off at this side with a wire brush, then you've got very little resistance. Whereas you go up the scale between grinding, mechanical polishing at various scales, and the top one that we would recommend is pickling and passivation. Then you take off all of the surfaces, and the resistance to pitting is much better. So that concludes my talk. I hope it has been interesting. I appreciate that it's a little snapshot into stainless steels. Should you wish to know any more information, please feel free to use our contact details below. Clemente and myself are more than happy to receive any inquiries. Thank you.